Okay, today we are moving on to Unit 5B. It's actually really similar to the ellipses that we did in the last unit. Ellipses and circles as far as the equation goes, there's just a little bit different. We're actually going to start talking about hyperbolas. Okay, the easiest way to think of a hyperbola, if you look at it, it's basically an ellipse that was broken apart and turned inside out. Okay, so if I were to take this piece and turn it around the other way, and take this piece and turn it around the other way, then I would have an ellipse. So if you think about it, the easiest way, like I said, to remember it is to think of it as an inside-out ellipse. Okay, again, a horizontal ellipse is this, or a horizontal hyperbola is the same as a horizontal ellipse, meaning that it opens on the x-axis, where the horizontal ellipse was longer on the x-axis. And a vertical ellipse opens on the y-axis, just like a vertical ellipse was long on the y-axis. Okay, so we have hyperbola, and then of course our ellipse that was the oval shape that we're all used to. Okay, as far as the equation of an ellipse, if you notice, the only difference here is that it has a minus sign in between instead of a plus like it did for an ellipse. Okay, I like to think of it this way. In a plus from an ellipse, it held it together. Okay, a minus, if you think about magnets, okay, it pushed them apart. So it gives you the hyperbola look rather than the ellipse look. Okay, so the equations are very similar. Plus for an ellipse, minus for a hyperbola. Foci is still the same. A squared plus b squared equals c squared, same as it was for an ellipse. Okay, if you look here, here is another extreme difference. Okay, for a horizontal ellipse, since it's on the x-axis, the x goes first. Okay, if it is vertical, meaning our hyperbola is opening on the y-axis, then the y goes first. Okay, again, let's look at that again. Horizontal hyperbola, the x goes first because it's on the x-axis, it's opening on the x-axis. Vertical hyperbola, the y goes first because it is opening on the y-axis. Okay, they still have minuses with them and all that. Okay, the slope, if you are looking at the slope, if you notice the hyperbola has like this imaginary box right here. Okay, this box that kind of separates our hyperbola, and then these two slopes right here. Okay, the slope is always y over x. It's always rise over run. Okay, y'all should remember that from middle school. Okay, so your slope is always rise over run. So no matter what kind of hyperbola we have, whether it's horizontal or vertical, our slope is always going to be the number that's hanging out with the y over the number that's hanging out with the x. Okay, so this one looks like b over a, but that's because b is with the y. Okay, down here it's a over b because a is with the y because a goes first. Okay, so it's always y over x, so think about it that way. Okay, and the slopes are always the same. One's positive and one's negative. Same slope, positive version, negative version. Okay, flip it over and let's jump into some of these and see what we can figure out. Okay, first step is always determine if it's horizontal or vertical. Okay, since we are opening on the x, I know that my x is going to go first. Okay, the center of my little imaginary box is chilling right there at 0, 0. So I don't have to worry about the parentheses and plus minus or anything. So it's x squared, and then y squared is next. Just like an ellipse, they're always set equal to 1. Okay, if you remember, the difference between the ellipse and the hyperbola is the hyperbola has a minus sign. Okay, so let's see what number goes under the x. How many steps did it take us to get from the center of our box out to the x? It looks like, let's see, it's at the 2, 4, 6, 7. Looks like it's at the 7. So 7 squared is 49. And then the top of our box is at the 3. 3 squared is 9. Okay, so now that we have the bottoms figured out, it's really easy to figure out the slope. Remember, like I said, it's the square root of the number with y over the one with the x. Okay, so again, the y was 3. That's why we got 3 squared is 9. So it's plus or minus 3 over 7. Okay, plus or minus 3 over 7. Okay, and the foci are always inside the parabola, just like it was for the ellipse, and like it was when we graphed the regular parabola. Remember on the regular parabola, it said it had to eat the foci? Okay, so the foci is going to be somewhere right here along the x-axis. Okay, look back at your foci formula, which is right here. A squared plus b squared is the square root of c. Kind of Pythagorean theorem-ish. Oh, it's right there. Okay, anyway, so our foci is going to be 49 plus 9, and you take the square root of that. Okay, so 49, the square root of 49 plus 9 is actually 7.61. Okay, it's actually the square root of 58. Okay, and since we're on the x-axis, our x is the one that's going to change, so it's the square root of 58, and we're not moving on the y. And then it's negative square root of 58, and we're not moving on the y. Okay, so since it's 7 point something, it's actually about right here. That's an ugly dot. And there's your foci. Okay, let's move down to this vertical guy. Okay, because he's vertical, the y squared goes first. Then the x squared, always equal 1. Okay, again, here's our invisible box that is not really invisible because you can clearly see it. That was a stupid statement. Anyway, but our center of that box is at 0, 0. So the height of this is, oh, these are really hard to see. Looks like 2, 4, 6 of 3. Okay, so y squared over 9. And the width of this guy is 5. 5 squared is 25. Okay, remember your slope is always y over x. Okay, the number with the y is 9. The square root of 9 is 3 over 5, positive, negative. And again, our foci, 25 plus 9, take the square root. So we have the square root of 34. This time we're on the y. So our x value is 0. Square root of 34. And 0, negative square root of 34. Okay, the square root of 34 is actually 5.8. So it will be right here. And negative 5.8, which is right. Oops, that's not right. Right here. And right here. Okay, remember, it's inside the parabola. That's the biggest thing you need to make sure is that it's inside the parabola. Okay, let's look at example 3. Again, the first thing you need to ask yourself, is it an x or is it a y? Okay, some of you are probably saying, well, the shape of the parabola, or the shape of the hyperbola is almost an x. It's been separated. If it is an x parabola, or an x hyperbola, sorry. Okay, and this one almost kind of looks like a y. Okay, so that might be another way for you to remember if the x, the y goes first. Okay, but in this case it is an x, so we have x squared minus y squared equals 1. Again, that's a big determinant if it's a hyperbola or an ellipse. Because hyperbolas have subtractions, ellipses have pluses. Okay, go back to your little box right here. And it looks like it is 2 wide, so over 4. And the box is 2 tall, so also over 4. Okay, when we do our slope, we get plus or minus 2 over 2, which is actually a slope of positive and negative 1. Okay, and to get the foci, we are going to do 4 plus 4 and take the square root, so we actually get the square root of 8. Okay, the foci are on the x-axis, so we have positive square root of 8 with a y of 0, and negative square root of 8 with a y of 0. Okay, so the square root of 8 is actually 2.8, so it's almost 3 is where our foci are located. So they're located about right there. Again, inside the parabola. Very important that you notice it is still inside the parabola. Okay, flip it over. Okay, we are going to write the equation, slopes, state the foci, just like we did before. Okay, all of these hyperbolas are going to be located at 0, 0, so we don't have to worry about shifting them or moving the foci off of the current location or anything like that. Okay, so pretty straightforward. Okay, x or y hyperbola, it is a y. Here is our hyperbola right up here. Okay, don't confuse the hyperbola with the slopes or with the asymptotes that they have graphed. Okay, so kind of look for that. So it is a y squared first, minus, and then we have our x squared, always set equal to 1. Okay, let's go back to our box, and it is 5 units tall, so we are over 25 for the y. 4 units wide, so we're over 16 for the x. It's part A. There's our formula. Okay, our asymptotes are our rise over run, so whatever's with the y, square root of that, so we have 5, plus or minus 5 over square root of that, which is 4. And for the foci, add these up, take the square root. So we have 25 plus 16. And that gives us the square root of 41. Okay, so now we need to ask where the foci are. They're actually on the y-axis. So we have a 0x coordinate, square root of 41. And then the exact opposite of that, 0, negative square root of 41. Okay, moving on to number 2. Okay, we have an x parabola. Parabolas or x hyperbola. The parabolas are located right here on the x-axis. That means x is first. X squared minus y squared again equal 1. Okay, the width is 4, so we're over 16. The height of our box is also 4, so we're over 16. There's your equation. For your slopes, rise over run, so my y over my x is actually the square root, so 4 over 4, plus or minus, which simplifies to plus or minus 1. And this time your foci are on the x, so our y coordinate is going to remain 0. Okay, we have 16 plus 16, which gives you the square root of 32. Okay, so we have positive square root of 32 with a y of 0, and negative square root of 32, also with a y of 0. Okay, square root of 32 puts us somewhere around 5.6, somewhere in that vicinity for our foci. Sorry, I didn't do these. Over here it's 6.4. Okay, moving along to number 3 and 4. Another x. X squared minus y squared equals 1. And then, of course, stack them. The width of our x from the center to our actual parabola is 5 units. So that gives us a denominator of 25. And the height is 4, which gives us a denominator of 16. Our slopes are y over x. So in this case, 4 over 5. Remember, taking the square root, I'm actually using the actual heights for these. Okay, I'm using the actual width of 5 and the actual height of 4 for my slope. I'm not using the numbers that are already squared. Okay, so positive and negative 4 over 5. Okay, you can actually check yourself. Y'all remember how to find slope? Count up 4 over 5. It should keep you on that asymptote line. Okay, that's how you find slope. And our foci should be over here on the x-axis, so we're going to have a y of 0. 25 plus 16. Another square root of 41. Okay, again, y of 0, so we have positive square root of 41. Y of 0. Negative square root of 41 with a y of 0. Okay, then we have a y hyperbola. Y squared minus x squared equals 1. The height of our box is 3, so that's over 9. The width is all the way out here to 5, so we're over 25. Our slope is our rise over run, so our y over our x. Okay, again, the original numbers, not the ones that have been squared. So it's plus or minus 3 over 5 for the slope. And we have 25 plus 9 for our foci. This gives us a foci of square root of 34. Okay, again, they're going to be on the y-axis. So our foci are going to have 0 for our x-coordinate. Remember, these foci are really easy to find right now because we're at 0, 0. Okay, if we're sitting at 0, 0, the foci are much easier than once we try to move the hyperbola off the center. Okay, then we're going to have to start adding the foci to another coordinate like we did with the ellipses. Okay, these are perfect examples of test questions. Okay, the easiest way that we can ask a test question based on the graph of a hyperbola. Okay, a few things you need to notice, a few things that can easily help you eliminate answers. You notice the y squared is first, which makes it a y hyperbola. Okay, so we can eliminate this guy. He's an x hyperbola. B gets to stay, C gets to stay, D also gets to stay. Okay, and we notice that the y makes our box 4 units tall. And the square root of 25, the box is going to be 5 units wide. Okay, this is for our box. Okay, so since A is already eliminated, I'm not even going to bother with him. Okay, so let's go down here. Okay, so from the center up, we should be at 4, which he is, so he can stay. Center up is at 4. Center up is at 5, so he gets to go. Okay, from the center up, y'all can see that the parabola is actually at 5. Okay, that's not where we need it to be. Okay, so now we're looking for one that's 5 units wide. Okay, so look, these are only 2 options we have now. Okay, this box is clearly only 2 units wide. This one, if y'all can see, it's kind of difficult to see him. Let me outline him right here. Okay, and this one is 5 units wide. Okay, process of elimination is going to be your best friend on these situations. Okay, let's flip it over to these two. Minimize it a little bit, I guess. Okay, number 5 is an x hyperbola, so we are looking for one on the x-axis. Answer choice A is out for that guy. Okay, and we are looking for one that is 5 wide and 5 tall. Okay, so 5 wide and 5 tall. This one is 5 wide, but it looks like he's only 4 units tall. I know I can't really see the box on that one, can y'all? Zoom in and see if we can see it a little better. Okay, this one is definitely 5 units wide, but he is definitely not that tall. Looks like he's only about 2 or 3 units tall. Okay, I think I can see the box right here. It's very badly drawn. It's not very dark at all, but I can definitely see a line right here. Okay, so it looks like C is going to be our answer choice for that one. Some of these boxes are really hard to see. Okay, let's look at this last one right here on this page. Okay, it is a y hyperbola, so A is out again. And we are looking for 3 units tall and 4 units wide. Okay, so I'm looking for a hyperbola that's 3 units tall. This one is 4 units tall, so he's out. Okay, this one is actually moved off the center, so we can mark him out too. So that only leaves us with one answer choice down here at answer choice D. Okay, y'all see how this box is no longer sitting at 0, 0. Okay, if we have a plain old y squared x squared at the top, that means it's plus or minus 0, so he hasn't moved anywhere. So this guy being shifted throws everything off, so he's got to be marked out. Okay, let's do one more page and then we'll be done today. Okay, y squared minus x squared. So again, we have a y hyperbola. That's an x hyperbola. That's an x hyperbola. So we're down to 2 options, A and D. Okay, we're looking for 3 units tall, 2 units wide. Okay, this one is 3 units tall. Okay, from the center up is 3. This little fella also looks like he is 3 units tall. Okay, but you can see his box right here. He's actually only 1 unit wide. Okay, we need the one that is 2 units wide. Square root of 4 is 2. Okay, I can assure y'all that on the test, these boxes will be much more clearly labeled, just like they were in the examples that we did, like this. You'll be able to see those those boxes much more clearly than you are on these problems right here. Okay, and the last one, another x parabola. So I get to eliminate my y parabolas here. Okay, C and D right there. When I look at my equation, it's a x squared, y squared. Okay, that means there's nothing being moved off the center. If you look at C and D very closely, they have been moved. Okay, your centers are now not at 0, 0. They're at different locations. So these two fellows are out. Leaving this one is our only option. Okay, I know some of y'all are looking at this saying, well, he has a height of 0. Okay, remember you can't have a height of 0. That would be a flat line. You're actually stacked over 1, so he has a height of 1, not 0, which this guy does. And he's got a height of 1, and he's got a width of 3. And that is it for today. Again, feel free to go back, pause it, go over your answers, whatever you need to do.